So for number 22, the mass equals 8 kilograms. The velocity equals 2 meters per second. The equation is that momentum, remember we represent that with a small p, is equal to mass times velocity is equal to 8 kilograms times 2 meters per second is equal to 16 kilogram meters per second. On number 23, the momentum is equal to mass times velocity. On number 23, our mass is a 50 kilogram carton. Our velocity is 4 meters per second. Our momentum is mass, 50 kilograms, times 4 meters per second is equal to 200 kilogram meters per second. On number 24, I have a force of 10 newtons, and the time that it's exerted on a cart is equal to 2.5 seconds. I'm pushing on a cart and I don't let go of it. My impulse is equal to force times time is equal to 10 newtons times 2.5 seconds is equal to 25 newtons. For question number 25, if I double the time, in that case my force is still 10 newtons. My time is 2.5 seconds times 2 equals 5 seconds. My impulse is equal to force times time is equal to 10 times 10 newtons times 5 seconds is equal to 50 Newton seconds. Number 26, impulse is equal to the change in momentum is equal to the force times the time. So in 26, I have a mass of 8 kilograms and a time of, a velocity initial of 2 meters per second, and my final velocity is stopped, so it's 0. So my change in velocity is equal to, well, I don't need to do it that way. My initial momentum, my momentum initially is the mass times the velocity is equal to 8 kilograms times 2 meters per second is 16 kilogram meters per second. My momentum final is the mass times velocity. My final velocity is 0, so my final momentum is 0. Impulse is equal to the change in the momentum, which is 16 kilogram meters minus 0 is equal to 16 kilogram meters per second. And 27. When I say it's stopped, that means that the final velocity is equal to 0. My initial velocity, it tells me, is at 4 meters per second. My mass is 50 kilograms. And it is friction that is stopping the sliding. So that's what the rough surface means. My initial momentum is equal to mass times velocity is equal to 50 kilograms times 4 meters per second is equal to 200 kilogram meters per second. And that is my initial momentum. My final momentum is equal to 0 because it has stopped. My change in momentum is equal to the impulse is equal to the initial minus the final, so it's equal to 200 kilogram meters per second. Number 28. I have a 2 kilogram mass moving at 3 meters per second. And it impacts another mass moving at 0. The second mass is also 2 kilograms. My initial momentum is equal to mass times velocity is equal to 2 kilograms times 3 meters per second. In this case, because momentum is conserved, my initial momentum is equal to my final momentum, which is equal to mass times velocity. The final mass is both blobs together, 4 kilograms times the final velocity is still equal to the initial velocity, which was 6 kilograms times 3 meters per second. So 4 kilograms times the new velocity, the final velocity, is equal to 6 kilogram meter per second. If I divide both sides by 4 kilograms, which is just algebra. I end up with 3/2, 1.5 meters per second.